You're sitting in a commercial airplane. The pilot comes on the intercom and says you'll be cruising at 450 knots. You nod, like you understand. You don't. Nobody in that cabin does. Not really. On the ground, we use miles per hour. On the water and in the sky, we use knots. And the reason why goes back to a piece of rope, a wooden board, and a 30-second hourglass. Tool sailors used 400 years ago when the most advanced navigation technology in the world was a person standing at the back of a ship, counting. Before GPS. Before radar. Before any electronic instrument whatsoever. How did a sailor in the 1500s know how fast his ship was moving? He threw a piece of wood overboard. The device was called a chip log, or sometimes a Dutchman's log. It consisted of a flat, pie-shaped wooden board weighted at the bottom so it would float upright and remain stationary in the water. Attached to the board was a long rope, and tied into that rope, at precise intervals, were knots. Here's how it worked. The board was thrown off the stern. As the ship moved forward, the rope paid out behind it. A sailor held the rope, letting it run freely through his hands. Another sailor flipped a 28-second sandglass. When the glass ran out, the first sailor grabbed the rope and counted how many knots had passed through his hands. That number, those knots per 28 seconds, directly corresponded to the ship's speed in nautical miles per hour. The spacing between the knots was calibrated specifically to make this work. Each interval was set at 47 feet and 3 inches. Why that specific distance? Because 28 seconds is to 1 hour as 47 feet 3 inches is to 1 nautical mile. The rope knots were literally a mechanical analog computer, built into a piece of string. And the number of knots counted, that number is the speed. 1 knot means 1 nautical mile per hour. The unit and the physical knots in the rope are the same thing. Here's where it gets genuinely interesting. A nautical mile isn't arbitrary. It's geographic. 1 nautical mile equals 1 minute of arc of latitude, that is, 1/60th of 1 degree of the Earth's latitude. The Earth has 360 degrees of latitude. Each degree has 60 minutes of arcade. 1 minute of arc equals 1 nautical mile. This means that nautical miles are literally built into the geometry of the Earth itself. On any nautical chart, the latitude scale on the side of the map doubles as a distance scale. 1 degree of latitude equals 60 nautical miles. No conversion required. No multiplication. Just look at your chart, measure the distance with a compass, and read the latitude scale directly. For pilots and sailors, this is not a trivial convenience. It means that navigation calculations, calculating time to destination, fuel required, course corrections, are dramatically simpler in nautical miles and knots than they would be in kilometers or miles. When you're navigating across an ocean or managing an aircraft's fuel reserves, you want your math to be as clean as possible. The nautical mile was internationally standardized at 1,852 meters, approximately 6,076 feet, in 1929. The aviation world formally adopted knots and nautical miles after World War II, when international air travel required a single, universal standard. Knots 1. They've never been seriously challenged since. There have been proposals over the decades to convert maritime and aviation navigation to the metric system, to use kilometers per hour like the rest of the world. The proposals have all failed. The reasons are worth understanding. First, the geographic relationship between nautical miles and Earth's coordinates is simply too useful to abandon. No metric unit has that built-in relationship to actual planetary geometry. Second, the entire global infrastructure of aviation and maritime navigation, charts, instruments, training programs, air traffic control systems, international agreements, is built around knots and nautical miles. Changing it would require simultaneous, perfectly coordinated transitions across every country's aviation and maritime authority, at an estimated cost that runs into billions of dollars globally. Third, and perhaps most honestly, pilots and sailors are deeply conservative about anything that touches navigation safety. The history of aviation is full of accidents caused by unit confusion. In 1983, a Canadian Boeing 767 ran out of fuel mid-flight because ground crew confused kilograms and pounds when calculating fuel load. That flight became known as the Gimli Glider. It made an emergency landing on an abandoned airstrip with no power. The lesson was burned into aviation culture. You do not casually change units of measurement around aircraft. The knot is 400 years old. It was born from a piece of rope dragged behind a wooden sailing ship in the North Atlantic. It survived the age of steam, the invention of flight, 2 world wars, the space age, and the digital revolution. It is used today in the most sophisticated aircraft ever built, communicating with satellites and navigating at 40,000 feet. Not because we can't change it, but because it is, at its core, a brilliantly elegant solution. The Earth is a sphere. The sphere has coordinates. And the knot, the humble, rope-borne knot, fits those coordinates perfectly. Some tools don't get replaced. They get carried forward.